Hello, everyone. So I have today a webinar on probabilistic seismic hazard analysis, kind of from a structural engineer's point of view. And so we'll get right into it here. So an outline of the things that we're going to talk about today, just a review of some basic seismology concepts and some terminology that's necessary. We'll talk about what strong ground motion is and what strong ground motion prediction equations are. We'll talk about deterministic seismic hazard analysis as it uses a similar framework and is conceptually a little bit easier to understand than probabilistic seismic hazard analysis, but then we'll see how those concepts are all applied in probabilistic seismic hazard analysis. And then we'll talk, kind of depending on time, there's some additional considerations that we have as far as maximum direction of ground motions and response spectra, risk adjustment of the maximum considered earthquake hazard, and conditional mean spectrum. And so these are kind of newer concepts that are out there, and we will at least hopefully have time to touch on those three, with the emphasis really on the beginning of the information. So some acknowledgments here that some slides and graphics are from course notes used at the University of Washington. Some of those were originally developed by Steve Kramer, a geotechnical engineering faculty member here. Some slides and graphics are from the Geotechnical Earthquake Engineering textbook that is by Steve Kramer, first edition 95, and then some graphics are also from Elements of Earthquake Engineering and Structural Dynamics by André Filiatreau, Robert Tremblay, Konstantin Christopoulos, and others, third edition 2013. So proper acknowledgments for some of the materials used in these slides. Before we get into the review of seismology concepts, I do want to make sure we kind of understand the motivations for wanting to, for structural engineers understanding probabilistic seismic hazard analysis. Probabilistic seismic hazard analysis is used to generate the design ground motion parameters that go in the USGS maps that are referenced by ASCE 7 and used for ground motion, used to design buildings all over the US. Additionally, in more densely populated regions of the west coast of the US, say San Francisco, Los Angeles, Seattle, Portland, there are a lot of buildings being built now with probabilistic seismic hazard, with performance-based seismic design, or a lot of buildings that require a site-specific seismic hazard analysis. In these instances, a geotechnical engineer or a seismologist is likely going to be contracted to prepare the hazard for which structural engineers need to consider in design of the building. However, it's really important for structural engineers to have a basic understanding of that process so that they can communicate and really understand the hazard for which they're designing their buildings. And so that is the context for and the basis really used to develop this webinar, and actually a portion of the Earthquake Engineering 2 class that I teach here at the University of Washington that focuses on probabilistic seismic hazard analysis. Okay, so with that, let's get into the slides. And so the first section here is just a review of basic seismology concepts, and hopefully this isn't new information really for anyone. So a little bit of plate tectonics. So we have the Earth, a series of plates, crustal plates that float on top of the mantle, and it's a thermodynamic process that moves these plates around. The lower part of the mantle is hotter, upper part of the mantle is cooler. That creates kind of a flow that moves the crustal plates around on top. They essentially ride those currents. And of course, at the boundaries of those plates are where we have, at those plate boundaries, we have a lot of things potentially happening. We have plates that are converging, or plates that are diverging, moving apart from each other. So this is a very commonly used illustration from USGS, just illustrating locations where you have plates moving away from each other, plates moving towards each other, and kind of what can happen around those areas. Really what creates earthquakes are regions where the plates are moving against each other. So that would be shown in the kind of lower right-hand portion where you have a plate, a subducting plate moving underneath a continental crust plate. And so those boundaries, we can lock up high stresses and generate earthquakes.